Start by just asking, since this seems to be an audience of question askers, why do we educate? And I think when you hear this question, many different things might come into your head. Some of them are sort of like, we're humans, it's innate, that's what we've been doing. There's some sort of sense of tradition or historical precedent that we do educate. Other things could be we educate to create a job, a workforce, and to create an effective workforce. But in some ways, for me, one of the reasons as a society I think we ought to be educating is that we want to be training future problem solvers for problems that we don't even know exist yet. And so this sort of is a challenge. And there's a corresponding question, which is, I'd say, how do we educate? And so right now, a lot of education takes place in traditional classroom settings. We see that things are moving into massive online courses, but we also see that education can take place in more informal settings, online, on the job, from your peers. But I would argue that there needs to be some sort of correspondence between why we educate and how we educate, and that current education in universities, in some senses, it isn't necessarily training the next generation of data scientists to solve the future problems. And so sort of this was a challenge, I guess I saw myself, I'll explain to you first of all why I thought that I should teach a class and how I went about teaching it. But the two questions in a way underlying this whole presentation are to think that we should be thinking sort of more deeply about why and how we educate. So first of all, a few years ago I started, and I'm sure you can't avoid the big data hype. And sort of this goes hand in hand a little bit with what Kate was talking about yesterday with regard to the big data myths. And it's in the headlines everywhere, big data, including, for example, just in October, the data scientist being the sexiest job of the 21st century in Harvard Business Review. And my reaction to seeing this hype is both a combination of annoyance and skepticism. And I would like to go into detail about the annoyance. I'm sure you have maybe your own reasons to be annoyed, but for me, some of the annoyances, there are unclear definitions in the media and the way it's depicted in terms of words such as data science and big data. It's not clear what data science is. It's not clear whether data science is the science of data, the science of big data, what's big data, what's big, which industries or disciplines. Is data science only in the tech industry, or is it across disciplines? So the unclear definitions is one annoying thing. Another is that there's a lack of respect for the decades of work of scientists, mathematicians, statisticians, researchers, decades, maybe centuries that we just saw. There's this impression, that machine learning, for example, was just invented 2 years ago. And also that I fear that this hype masks that there is deep, real stuff going on, which I think we've been hearing about in this conference. So this workshop helps to take the hype away a bit. Except unfortunately, I think it turns a lot of really smart, interested people off from even looking at what's underneath because it's just a big turnoff. And finally, I'd say, coming from the point of view of a statistician, which I am, I have my PhD in statistics. When I go and talk to statisticians, pretty much universally they say, isn't statistics the science of data? For them it feels like identity theft. And the president of the American Statistical Association 2 years ago wrote, we need to tell people that statisticians are the ones who make sense of the data deluge occurring in science, engineering, and medicine, and that it's statisticians who are providing the methods in all fields, from art history to zoology. So that's the reaction from my discipline that I grew up in. And I would say that, in a way I feel that she shoots herself in the foot a little bit from saying art history to zoology, by which she means A to Z, except it sounds very antiquated and not really, in touch with what the hype around technology is. So I'm sort of torn when I see stuff like this. And I think other fields probably have similar problems with data science. Also, I feel that there is a culture of charlatans, frauds, people focusing on self-promotion and being rock stars and celebrities and not on the underlying ideas. And I find that really troubling. And so then I want to tell you a little bit how I got over being annoyed, more or less, which is that I worked at Google for several years, and I thought I should reflect on my experience at Google, which felt like when I got there, the job title data scientist didn't exist yet. My job title was basically statistician, so it was sort of like being a statistician in computer science land, which I'd characterize in some of the following ways. First of all, a traditional statistics curriculum, you learn about statistical modeling, and a lot of those models are very much about, you build those models in order to find some sort of interpretation of reality. Your parameter estimates have real-world corresponding interpretations, and your goal is to somehow describe or explain the world and try to model the underlying generative process in some sort of probabilistic sense that generated the data. Whereas I would say that the culture of computer science somewhat is more, it could be the exact same model, like linear regression or logistic regression, but the goal of those models oftentimes is to predict something, or to maximize or optimize click-through rate, or to get people to click on something. And when you build models, we heard earlier this morning, for example, about models that include thousands of features. When you build models that have tens of thousands of features, meaning predictors or variables in them, it's a totally different mentality, because you don't want to interpret the parameters. They don't need to be interpretable. They just have to sort of maximize some sort of performance metric or evaluation metric that you care about. And this is a very different sort of point of view and way of thinking, and it's a different paradigm. So for a statistician, that's sort of new. Other things is that as a statistician, you do end up, even though you're at Google, you have to do the work in the engineering infrastructure. So you are the one, sort of how Itamar described earlier. You are the one sort of getting involved in the engineering and the coding. You're working with the logs directly. You're not getting a nice, clean data set handed to you. You're in the whole engineering pipeline. And so you have to do a lot of coding, and you also are doing statistics at scale, meaning that a lot of things like matrix inversion that you need for linear regression, for example, breaks when you start doing massive data sets. So there's a lot of challenges that happen to statistics when you deal with it at scale. The other thing is that we also heard from Itamar that Facebook is focused on this massive experimental infrastructure, which Google also had, and which has both engineering challenges from the point of view of just being able to divert traffic. So this is A/B testing. You may be testing out an algorithm, or you may be testing out some new feature on a user interface, and so you want some of your users to have one experience and others of your users to have another experience. And so that's an engineering challenge, but it's also a statistical challenge in terms of developing the right metrics, and in terms of not wanting to have multiple the same user could be in 10 different experiments. So how do you handle the different effects being caused by those experiments? So, and there's multiple comparisons issues that he brought up. So those experimental design on this level is not, there's still, new developments need to be made, but also assumptions of experimental design, for example, that your users are being randomly assigned and can be considered to be independent of each other, don't hold in these settings, especially in social network settings where the users are directly connected to each other. If I'm in one arm of the experiment and my friend is, or my sister, whoever's in the other arm of the experiment, we're affecting each other. Her behavior on this, she could be in the treatment and I could be in the control, but I'm getting an effect of the treatment because she's experiencing it. So there's whole experimental design issues that are interesting. And so I reflected on all this stuff, that there's a lot of new stuff going on here that wasn't part of what I learned, in a traditional statistics program. And I would also say that I sort of formalized it to myself as that there is this data science process where you have the real world where users are, if we're thinking in terms of like Facebook or Google, you have real world users interacting with your product. Raw data gets collected or logged, but decisions have to be made by the data scientists or the engineers about what data they're going to record, what aspects of the user's experience are they recording. We heard about the tremendous amount of work involved to eventually get a clean data set, and cleaning the data set can create statistical issues of distorting the data. If you remove outliers before you impute missing values, that's different than doing it in a different order. So there's a lot involved in just getting to a clean data set. And then we also heard that once you get the clean data set, there may be issues in logging, that things weren't getting logged that you thought were getting logged, or that, and so you have to go back to the beginning and maybe go tell the engineer that, can you please start tracking whether the user clicked on this button because we seem to be missing it. And so then once you actually do have a clean data set, then you have these machine learning algorithms that you might build on top of it, and statistical models. And so I would then distinguish here between two things, two broad categories of why you might be building these algorithms. The first is, for example, if you're building something like a ranking algorithm or a recommendation system, it's to be integrated back into a data product, for example, a friend recommendation or system, which then gets integrated back into the real world and starts generating data itself. So we have this whole feedback loop where you, the data scientist, are actually creating a product that's generating data, which you're then analyzing and building. And so it's this whole feedback loop. And so this matters for at least two reasons that I can think of. One is you need to be taking that into account into your analysis, because you're basically causing the data yourself. And the second thing is that that we need to be taking this into account from ethical points of view, which we've covered a lot in this conference over the last couple of days, but that certainly is not generally part of a curriculum in statistics. Ethics never comes up. And so the idea that these models are actually going to be integrated into public policy and impact human life is really an essential part of this whole process. I would say that one category of these algorithms is to build data products, and the other is a lot of what Itamar described, which is that you're then sort of trying to describe the overall landscape of your product, which you then want to communicate, visualize, and report to the key decision makers in your organization, who then make decisions about what they want to do. For example, they may want to change the news feed or whatever. But so this whole cycle, this whole ecosystem, you have to be aware of when you're a data scientist. You're not just getting a clean data set and building a model. You have to be involved in the whole cycle, and that whole cycle needs to be taught to students. And so I'd say this isn't what I learned in school. And so, sometimes when I've said this to statisticians in particular, they say this, well, that's just the difference between industry and academia. And it's not just the difference between industry and academia. It's the reflection of, that there's this whole new field emerging, and it needs to be taught. And so, so that was my experience. And I'll just say that once I reflected on my experience at Google, and I started getting, I started to get convinced that this whole hype, that there was reality to it, and I wanted to sort of confirm it a little more, so I did exploratory data analysis. Andrew Gelman was my advisor. He's a statistician who has this book, and sort of buried in the back on statistical graphics, he says, long before worrying about how to convince others, you first have to understand what's happening yourself. And so that's how I feel about exploratory data analysis, directly with data, but also about what I was trying to understand about what is this data science thing that, I'd started to convince myself. I certainly wasn't ready to convince others. I don't necessarily even like convincing people, but I sort of wanted to explore this even more, which I did by asking lots of people who I worked with at Google about what they thought data science was, what they thought their job involved, talking to people in Silicon Valley. So I live in New York, but I was actually working out here a lot. And so I talked to people at tech companies, and also talked to people in New York about their jobs. And so that was one thing. And it was very informal, just like over lunch and coffee. It wasn't definitely a serious qualitative study. I also, sort of investigated what people online were saying, and we heard about we heard from the first data scientist at Facebook, and when you read about this conversation that Jeff Hammerbacher had, he was at Facebook at the time, now at Cloudera, DJ Patel was at LinkedIn at the time, that they had this conversation in 2008 about these sort of talented, creative people who were really good at asking questions and that could deal with could deal with the data. And they needed a good job title to attract the right kind of person, because apparently statisticians weren't the kind of person, or using the title quantitative analyst wasn't getting what they wanted. And so they came up with data scientist, even though they also had considered data artist. And so in 2008, this term data scientist gets coined. I think you probably understand this at this point, that I started, understanding that there are these similarities between these tech companies, that what we are seeing was that there are humans interacting with machines, and this is the result of, over the last 10 years, humans or 10 or 15 years, technology actually being cool now, and people carrying around mobile devices. I feel when I was in high school, it was certainly not cool to go home and be on your computer after school. Now it's cool. So humans have let machines into their lives, and one thing in particular is that's creating time-stamped event data. That's one of the data types that we see now, and these companies all want to build user-facing products where the raw material of those products is data itself, and a lot of times it's social data or human-generated data, and it took interdisciplinary teams one of my colleagues from Google here, he was a physicist. We had social scientists, engineers, statisticians, and you got the sense from Facebook and LinkedIn that they also had to have these interdisciplinary teams. Ethnographers obviously would be a good addition. And so I also want to bring up that in 2001, Bill Cleveland, who was at Bell Labs in the statistics research group, wrote a paper on data science, an action plan for expanding the technical areas of the field of statistics, which didn't really catch. But in terms of it's not like the statisticians took it up as a manifesto to expand the field of statistics. But he did mention that we needed multidisciplinary investigation, models and methods for data, computing with data, pedagogy, and tool evaluation. So those were sort of So I guess the point here is that the term data science existed. It's not necessarily what data science is now, but it's sort of been kicking around in in the atmosphere. So I just want to say that all this sort of goes into why I wanted I proposed a class at Columbia, because I felt that I wanted to bring back to the students everything that I sort of was experiencing, and I was convinced at this point that they weren't going, that they need to be competitive on the job market. On the one hand, I wanted universities to start. Some universities were already doing it, but I wanted Columbia in particular, because that's where I was involved, to start sort of pushing back a little bit on industry and the media in terms of legitimizing data science and big data as sort of a deep, rich research field. And so the central question of the course was still, what is data science? So despite the fact that I proposed this class and was going to teach it, I still made it the underlying theme of the class for the entire semester. The challenges of the course for teaching it for me were, first of all, I was teaching a course where the topic is still getting defined. There's no existing textbook or well-defined body of knowledge, but I took it as an opportunity to help define it. Over the summer before I taught it, I felt like I was in a sort of state of panic a lot of time, because I had about 20 different textbooks, from experimental design, data visualization, Hadoop, classical statistics textbooks, trying to figure out our machine learning algorithms, how do I put this all together in one sort of curriculum when there's not one book, which is usually one of the ways that makes teaching easier sometimes. Another thing is that I really wanted to try to simulate the chaos of the real world in an academic setting for the students, because I felt that that the sort of the nature of getting a nice, clean data set and then being told to run a linear regression on it really wasn't getting them what they needed. And I also wanted to embrace this sort of tension between the set. On the one hand, I wanted to teach them a set of tools and best practices, but then on the other hand, I wanted them to sort of to start thinking of this as a deep discipline with historical, being built on the deep disciplines of statistics, computer science, sociology, everything coming before it. And I also wanted to keep the hype at bay. And so the class was called Introduction to Data Science. It was offered in the fall. And I taught it in the statistics department. I was technically I'm an adjunct, and I was a Google employee at the time. I had these weekly lectures, but then also to supplement it, I had labs and problem sessions, which I had a TA and a lab instructor. And I was asked to have no official prerequisites. It was offered at the master's level. But I sort of wanted to be able to assume linear algebra, statistics, and some experience coding. But what happened was 60 students showed up, and I was expecting statisticians, mathematicians, and computer scientists. But it also ended up being sociologists, biologists, bioinformatics, journalists, urban planning. And so, I really had to supplement some of their, it was very varied backgrounds. Also, there are undergraduates, masters, students, PhD students, postdocs. There are also part-time working professionals because it was held in the evenings. And professors also came, much to my surprise. And so what did this reflect? It reflected partially that data science isn't just what's happening in tech companies. It's that at universities, researchers are struggling now with all these computational challenges across disciplines in sociology and biology, genomics, urban planning. They're all struggling with these same challenges that, that some of the innovation may be happening technology-wise in the tech companies, but all these people now want to be trained in these tools. And so I started with some priors for the class. First of all, the first prior, there are three of them. One is I just decided to start with the assumption to define data science as data science is what data scientists do. So then it's a natural question, what's a data scientist? And Josh Wills, who I worked with at Google, defined data scientist as a person who is better at statistics than any software engineer and better at software engineering than any statistician. Josh is now at Cloudera. And then Will Sukareski from Kaggle countered with a person who is worse at statistics than any statistician and worse at engineering than any software engineer. And so data scientist, I guess you could say to start with a working definition, could be a computer scientist, software engineer, hybrid statistician. If we're defining data science to be what data scientists do, well, it's this whole laundry list of stuff that we've heard about, so I just sort of made this list up, and I didn't show it to the students at the beginning of the semester because I thought it would scare them, partially because it's completely disorganized, but also because, it's just it's a ton of skills, and sort of also, it's skills, but also habits of mind, like the ability to tell stories and interpret and investigate and conduct research and ask good questions and have data intuition and curiosity. And how do you teach? You sort of want to teach both these sort of more human abilities as well as skills like build a data pipeline that processes these logs and then joins it with this other source of data. And so you want to have all of this in sort of one class. And so I kind of loosely bucketed these into my third prior, or my second prior, the data scientist profile. I made this up at the beginning of the semester. I said, okay, let's say you need these 7 buckets of skills, essentially, in terms of traditional academic disciplines, or maybe not traditional, but data visualization, machine learning, math, statistics, computer science, communication and domain expertise, where domain expertise could be sociology or social sciences if you're at Facebook, but it could be biology if you're working with genomic data. And let's just say that these skills represent my profile. So I'm relatively the best of these skills. I'm best at statistics relative to myself. And I just sort of put this as a straw man. I put this as a point of discussion, and what happened was throughout the semester I had different guest speakers, and each time I asked them, what is your data scientist profile. And they all would say, this profile is bad because, for example, the y-axis makes no sense. What's an expert? There's no, who are you? How do we compare two people? Or, this represents a totally statistics-centric point of view, domain expertise, that just, to other people, domain expertise is their whole thing, right? So I mean, but this was a sort of a point of, an attempt to sort of just standardize a discussion about what is a data scientist, and, as a point of discussion. My third prior for the course was the data science process, which I told you about. And so then I engaged the community, the data science community, by having guest speakers pretty much every week from a lot of the companies that we've seen today, including Google, Microsoft, Kaggle, Cloudera, Claudia, who's coming in the next panel discussion. She was one of the speakers in my class, and also had some professors from the journalism school and the Department of Statistics. And so I had them coming in and speaking, and they were data scientists, and so this was to continually investigate the question, what is data science? What do data scientists do? And so part of it was for them to describe their process, for them to describe sort of the challenges they faced, to describe the things that didn't work as much as the things that did work. And each time they had to show their data science profile. And each time I asked them to propose a thought experiment to the students. So examples of thought experiments were things like, can you use data science to define data science? That was mine. And other people had things like, if we could observe all the world's transactions, what would we do with it? Or some of the questions that we've been examining in this conference would make good thought experiments, such as, what should happen to your data after you die? And especially in a statistics department, maybe, in this school, it's sort of more common to have these kinds of conversations in a statistics department, sort of having these more ethical, philosophical conversations, what I think was really important. And so the students would sort of talk about it. And so this sort of more ethical, philosophical dimension, I wanted to permeate the class as much as the engineering and statistical tools. And so, throughout the semester, I tried to have some sort of cohesion, but there are many threads running through it, including algorithms and models in context of what people were doing in their jobs: ethics, coding, data visualization, question asking, trying to come up with process. Communication and journalism, communicating being extremely important because of being able to interact with people of different disciplines, vocabulary being an issue. I mean, even for me at Google, the vocabulary of a statistician isn't necessarily the same as the vocabulary of a computer scientist, but then you realize you're basically talking about the same thing. Experiments in statistics, A/B testing for computer scientists, features for computer scientists, whereas maybe predictors or explanatory variables, and exploratory data analysis, sort of like taking time and really examining the data, not just building a model just because you can, not just building some big complex system just because you can, but getting the fact that you can get pretty far with just sort of exploratory data analysis. And also, so I bring this up that to document the class, I created a blog, and I bring this up because I consider this sort of how do we educate. So this was sort of one of, it's outside the traditional setting of, I think other people create blogs too, but it's sort of a new way of educating, I think. And so Math Babe, who is my friend and coworker, she has a PhD in math. She came to every class and she blogged every class. So she was documenting all the lectures. And then I also created my own blog to sort of reflect on what was actually a fairly intense experience for me teaching this class, because I was constantly trying to really understand how to piece this all together in something that made sense. Also, the final exam was a Kaggle competition. And so students, so basically Kaggle is very cooperative in this regard. They provide the data set and the infrastructure for doing it. I mean, it made it extremely easy. And basically the Kaggle competition was an essay scoring competition. So students were given essays written by, let's say, fourth graders, many different, so there would be a writing prompt, and then there'd be essays, text that had actually been written for students responding to the writing prompt, and then humans had graded, there were human graders, And so every essay, I think, had maybe 3 human grades, and there was some sort of calibrated reconciled score which somehow weighted these 3 human graders together. So the students then had to create an algorithm that would predict for a given essay what score it should get. And so basically you're automating the essay scoring or essay grading process. And so the fact, I consider this a positive thing, that by the end of the semester, every student in the class was able to write a predictive algorithm that could grade essays. But also we talked about the ethical aspects of this. I mean, do you want machines to automatically be grading your essays? The other thing that I also would like to bring up is we heard earlier today that Kaggle ranks data scientists from 1 to 100,000, and there's no women in there, at least not in the top few hundred. And that's because the women aren't entering. But a woman won in my class. So I think that when we consider these ranking algorithms for how we're evaluating data scientists, we should take into account the biases there. And so basically, when in a supportive environment, I think the women obviously can compete just as well as the men, but they just may not want to. And that's a whole other question that other people probably can answer a lot better than me. So some of the themes that emerged by the end of the semester were things like, and these are these are themes that seem to resonate in particularly with the students. One was all algorithms are editorial, that when you're building an algorithm, all the choices you make in cleaning the data and figuring out the evaluation metrics, in figuring out what models to use, what features to use, it's all human. Emily Bell's a professor of journalism at Columbia. Oh, did it go off?
No, you're on.
Okay, thanks. Another theme was this sort of theme of humans versus machines. So both, things in terms of like, do you want machines to be how much of what humans do you actually want automated? How much of human, creativity can actually be automated? And so this is sort of one of the underlying themes of these sort of softer human skills versus the harder core engineering and statistical skills. Another was the students ended up improving my data science profile by creating these stars of data science. So they each one of, if you just look at the center, they put these buckets of skills as spokes on a wheel, and then they surveyed the class, and basically each dimension was how students somehow sort of rated with respect to different skills. But they also divided it across disciplines, and so there's the different. So basically what I want you to get here is, one, there's variation among the individuals in the class, and there's variations among data scientists, and that, really to solve data science problems effectively, you need collaboration among the variety of individuals. And so I encouraged a lot of group work in the class, but I also think this isn't just about my class, this is about what it's going to take to solve data science problems, broadly as a society. Another one of the themes was this notion of causing the future, that these algorithms are getting integrated back into products that affect society and policy that affects society. And finally, there's this quote by Jeff Hammerbacher that the best minds of my generation are thinking about how to make people click ads. That sucks. And so, in some ways, the students were getting a biased sample of data scientists because they're all from industry, and they started getting this impression that a lot of them are focusing on these problems, but it's actually true that a lot of the jobs are in these areas, so that's where people are going. But the students, this concerned them, concerns them. So what's next? I'd say, well, first of all, Columbia, not because of my class, but sort of independently, there's the Institute for Data Sciences and Engineering now at Columbia, and we're offering a certificate program in the fall, which will have 2 classes from computer science and 2 from statistics. But also, more importantly, there's eventually going to be a master's program, and there's these different centers, Center for Smart Cities, a Center for Health Analytics, so it's, reflect the Center for New Media, and any master's program we're building is going to sort of reflect this cross-discipline nature of data science being applied across sectors. This is pretty New York-centric, but NYU also recently announced the NYU Center for Data Science. So now universities are building these programs, and I know that there's interest in you are building a master's program here as well. let me see. And as an output of this course is that there's a book which is sort of it has all the contributions from the guest speakers in it, which is coming out in September. So I'd say I mostly got over being annoyed. I'm still skeptical, but I'd say skepticism. I don't mean I'm anti-big data. I still have a lot of hope. I mean, but I would say skepticism is basically question asking, and we're question askers as scientists and researchers. And so I just think that this, as we've been doing over the last couple of days, we need to be continuing to ask questions. And so I'm still a skeptic. I still consider myself a skeptic. And to that end, we've recently started a data skeptics meetup in New York City, I would say, that this is to sort of combat the hype and have these continued conversations. And I'd say this is also where education is happening in our society. A lot of people are going there to get their information about data science, not to my skeptics meeting, but to meetups in general. So I say there's definitely something to this thing, data science, but still, did I really answer what's data science? And I would say that if you consider the space of all the world's problems, in terms of dimensions, massive data, small data, different domains, questions from genocide to cancer to climate change to personal relationship problems, like that girl won't go out with me. Some subset of those problems can be solved with data. Which subset is a good question. Who's going to solve them? How will we train them? I think we need teams with mixtures of backgrounds and skills and access to engineering and computing resources. And we want to be able to map the space of problems that can be solved with data to the teams of people whose skill sets could construct solutions to those data. So rather than these individual profiles, we need to construct teams, and these teams, these sort of data science team profiles should correspond to the profiles of data science problems. And so, then if we define data science to be the study of the space of problems that can be solved with data, that's currently my working definition. So just some final thoughts. I ask you, are we adequately preparing future problem solvers as a society? I consider education to be sort of a form of revolution in terms of trying to reform society, in terms of trying to create army of next generation data scientists who can go on and are equipped to solve our problems as a society. And so I'm offering the course again in the fall, but it's going to be different. And so I just would leave you with these questions. How do we educate, and why do we educate? And those are the questions that motivate me. Thanks.
Thanks, Rachel. A very helpful antidote to all the silliness out there for the last couple of years. You alluded to version 2.0 of the course. Are you at a point where you can say, if I'm doing this over again, I would teach a little bit more of this, and I would teach a little bit less of that?
Well, I think I almost had a personal bias where I didn't teach enough statistics because I had assumed prior statistical knowledge, and then I realized that they didn't have it. And so that was one of the problems. I'm going to co-teach it with a Google computer scientist so he can make up for some of the skills I lack, including data visualization. I don't consider myself to be an expert in that, and we need more of that. So it's sort of more like maybe rebalancing some of the emphasis. But I feel pretty proud of what was accomplished. But on the other hand, it was just a lot, in one course. And so that's why I do think a master's program, it needs to be a master's program. I think I made the students work a lot. But I've gotten a lot of positive feedback from the students. Though, so for the most part, I think students, went on, got jobs, and are felt like they sort of were able to be in this investigation with me, but I got some comments like enough sort of angst over what is data science. So, not everyone likes thinking about it like that. So.
Great talk. Glad I caught you this time after missing you a few weeks ago at Davis. Excellent. And you were one of the few people who touched upon a question that has bothered me for a while on this, which is the role of models and how far the pendulum seems to be swinging away from just because we have so much data, we can toss 200 or 400 years of scientific kind of epistemological building of the notion that we understand nature and society because we build models that are predictive and we build models that we can interpret. Can you maybe expand a little bit on that, since you seem to actually be worrying about these questions?
I mean, the only way I can expand on it is that I try to raise awareness about it, and that I think that universities have the opportunity by creating these programs to start, codifying what the body of knowledge should be, and that it's not just that. But, I mean, the only way is education. I think different people are going to think about it from different perspectives, including policy and regulation and things like that, which I'm not an expert in. But I think, everyone in this room has their own perspective, and that if we're all thinking about it, it can be more of a force.
So expanding your course into a master's program, what do you think is the right starting point for someone at the beginning?
You mean a student?
Yeah.
Well, yeah, that's been a big question. I mean, even for the certificate program, prerequisites has been a problem. Can we assume that people know how to code? I don't think so, because I think a lot of really talented potential data scientists haven't had to code yet. Right now, for example, in the certificate program, we're sort of looking for quantitatively minded people, and then giving suggestions for how they can build up their code when they come in. But there's going to be some steep learning curve in picking up code. I think in general that's another thing that we need better education sort of earlier on in that people need to at least learn how to code. I don't know. I mean, my definition of data science keeps expanding, and so I don't know that just statistics and computer science and math are the only prerequisite knowledge, but I do think those are some of the foundations.
This is a conversation that we're going to all be continuing in the community into the future. I want to thank Rachel again.